Now we go to reaction number 2, which is called what? Elimination reaction. Now, to eliminate is to remove something. Now, I want you to listen here. The substitution. You start with 2 compounds, 2 things. You happy? In the beginning, you've got this one plus that one. Am I right? At the end, you still end up with 2 things. Begin with 2, end with 2. Only the swapping took place. You got it?
Yes.
All right. You are going to see now something that is this. You had something like this. It was 1. Okay? It splitted into 2. So it was like we removed the B. So the B was removed. It's eliminated. Can you see that? There's no swapping. We are removing it. Then the same one, you can have it in reverse. You've got 2 things. Can you see now? A and B. Then at the end, they give you 1. Remember the other one? I begin with 2. I end up with 2. I just swap them around. It's substitution. It's alkanes, single bonds, and halogens. Begin with 2, end with 2. Making sense, no? Okay?
Yes.
Now, elimination. Let's read some facts. Any reaction in which atoms are eliminated from another molecule. So we're removing them from what? Another molecule, singular. So that means is this one. You start with 1, you end up with what?
2.
Like this beautiful bottle of mine. You see it as one like this, right? With a cap, nah? Then I remove the cap. Now I end up with 2. They were joined. Now they are separate. Aha. See, you're learning something, nah? I'm taking nice and easy. See, I'm not rushing, nah?
Yes.
It's sinking good, nah? All right. Now, this can be done by this. Now, I'm going to show you how to remember this. It's very easy. All right. Normally, we must have, at the end, you must have to, you have something, you must have something, H with something. Okay, first we can say H2. H2 is a gas. Did you know that? Remember the halogens? They are all gases. So your gases, if I put a periodic table, you have the whole group 7. You've got oxygen. You've got hydrogen. You've got helium. But no, don't worry about helium. Let's forget it. Let's say hydrogen, oxygen, and group 7. I want you to think of that. Or you can think of water. Water is composed of what? Hydrogen and
Oxygen.
And then you say group 7. So you are always going to combine 2 atoms. Whichever you combine, you are always going to have an H and something. It's either I'm going to have the H with an H, because it's an H with a gas. Or I'll say H with a gas. One of the gas, it's H by itself, which is that H2. Can you say that? Or you could say, but one of the gas is oxygen. I can have H with an O. Can you say? which is H2O. Can you see that? All right. Or I can have H with chlorine. Anything group 7, eh? Chlorine, bromine, fluorine. That's why they put X. That X stands for the halogens. Okay? We're together, ne? Yeah. All right. Here we go. Let's go. I'm going to introduce a term. So which means first, we are going to remove the H. 2. We remove H and H. We remove H and X, H and chlorine, H and fluorine, H and bromine. Can you see? It's H and something. Or we remove H and oxygen. Can you see? We are going to form double bond. All right. So, elimination reaction. This process, okay, they said the loss of H2. I said I'm going to give you a word. A word that I want you to remember is this one. The prefix D and the genation part. When you remove in chemistry, you will use the word D. And whatever you are removing, the name of the thing you are removing, it will end up with genation. We good? If you are removing hydrogen, it will be D. Hydrogenation. Got it? If I'm removing oxygen, it should be deoxygenation. If I'm removing Peter, it must be de-Petergenation. If I'm removing an iPhone, it's nice, no? De-iPhonegenation. You get it? That means you are removing. You are eliminating. We good, ne? All right. Sometimes if you're removing water, you can say de-watergenation. But water has another name. It's called hydrate. So they prefer that word hydrate instead of the water, so that you can say dehydration. Yeah, you remember I say I'm dehydrated. You people, they say that. Eh? Why can't they say I am dewatergenated? Yeah, it's good. That one is right. Or they can use the word for water, aquane, and say deaquagenation. Now they just chose the other one to try to throw us out of the game, but we baka them, yeah, they cannot play games with us. All right. So that is when you remove. You sit by that word D. Now listen to me. I want you to hear. I want to say something because the teachers are going to say something different. You know, I fight teachers. Like I tell you, log and exponents are the same thing. They're not inverses. I get, you know that now. You know better, but the teacher has been telling some funny thing. All right, listen to me. I said there are 4 reactions you're going to learn. Yes. You're going to find out the teacher will say maybe like something like, guys, there are 12 for 10. There are more than 4. Because under elimination, the teacher will say, we've got a reaction called elimination. But do you see here in the elimination, when we get rid of hydrogen, we call it what? Dehydrogenation. Then he says there is another reaction called dehydrogenation. It's not another reaction. It is still elimination. It just depends what are you eliminating. You got it?
Yes.
Yeah. It's just 4. But he won't show you that, no, guys, this is elimination. He will say, we've got elimination, we've got another reaction called dehydrogenation, we've got another one which is called dehydrohalogenation, and then we've got another one which is called dehydration, and so on. Meanwhile, it is one reaction, it's elimination. We good? All right. I was settling that one. Remember, let's go back in time. These are the three things we're going to get rid of. It's hydrogen with some gas, you know, H and H, H and group 7, H and O. Am I right? These are the three. We are going to eliminate these guys. All right, so here we go. First, we are going to get rid of what? Hydrogen. We good, ne? So the process, this process is often referred to as dehydrogen. Do you see that hydrogen? That's the one that's going away, am I right? So it's dehydrogenation, or simply elimination of hydrogen gas. So now, in this one, watch now. If you get rid of hydrogen from this carbon here, this is important. You must get rid of another hydrogen in the carbon connected to another, in the neighbor, next door. Okay? Exactly next door. Because you want to form what? Double bond. Can you see where I'm erasing? Those ones are gone. Once they are gone, by now you know there is a bond here. Am I right? And then how many hydrogens did I remove?
2.
Then it must be H and H. Why do I write H and H if I can just write it as H2? You see? Is that product. Can you see? You got double bond. Can you see? One, because it's two things you are removing all the time. One from this carbon, one from the one next door. Then you've got your double bond. Can you see that? They say heat is a what? It's a catalyst. All right, now watch now. They say this type of reaction takes place in industry in what is known as a catalytic cracking unit to break things apart. All right, we remove hydrogen, so it's called dehydrogenation. Next one, we are going to remove hydrogen and one of the group what? Remember group 7, you got bromine, chlorine, fluorine. Am I right? You can call them by their name one by one, or you can use the collective term, because that group 7 is called halogens. Isn't it right? Let me first do this. Let's put Cl now, for now, chlorine. Tell me, what am I going to remove if I put H and Cl? What must be removed? Let's come back here. Here, what was I removing? I was removing two things here. Talk to me. What was I removing?
Hydrogen.
And so it's just hydrogen. So I remove dehydrogenation. We good, nah? Okay, so I use that. So I was supposed to say dehydrogenation. Repeat the hydrogen twice. But since it's one, it's just, you know, when you solve for x, you get x is 2 or x is 2. You don't have to write it twice, nah? You say it once, nah? X is 2. All right? So here, what will I be removing? If it's hydrogen and chlorine, what am I removing? Hydrogen and chlorine. So this reaction, if there is a chlorine, it should be called dehydrochlorogenation, if there was a chlorine. But what if there was a bromine there? I'll be removing what and what? So it should be called dehydrobromogenation. It's making sense. What if there was Peter there? Dehydropetagenation. But now they figure out, they say, come on, guys. It looks like we're going to have many names. Since it's group 7, why can't we just, instead of saying chlorine, fluorine, let's just call them halogens? So which means I'm removing hydrogen and one of the halogens. halogens. Whether it's chlorine, fluorine, it doesn't matter. Can you see that? So I'll be removing hydrogen and the halogen. So now what will you call this reaction? Dehydrohalogenation. Where the halogenation, that's where chlorine, fluorine, you know what I'm saying? Yeah. That's why the name is dehydro for hydrogen. Halogenation. Can you see it looks like a long name, but it's not. You can figure it out yourself now because you understand. Alright, fine. So we look at this reaction. Do you see this reaction now? I must remove this one, the X, which is a halogen from one carbon, and remove the H from the neighbor one next door. Then I'll form what? A double bond. So what have been removed? It's H and X. That X could have been chlorine. We good, ne? So I'll be having hydrogen chloride or chloric acid, or hydrogen bromide or bromic acid, like how we had last time. Remember that? Yeah. So you just have to know we are always removing a hydrogen bonded with the gas, the hydrogen itself, the oxygen, which is water, and the group 7. Okay, I hope it makes sense to you. Alright, so you can see the results. Now, they say the base extract at proton H plus and X to the one. Don't worry about that. Don't need that. Now we're removing water. Am I right? Actually, we are going to remove, here's how you write water. Let me show you. Water, we say it's H bonded with an OH. Do you remember an OH when you're doing alcohols? You did primary, secondary, and tertiary alcohols. Am I right? Did you get the videos?
Yes.
Oh, okay. I was not in a rush also there. You checked?
Yes.
Yeah, because I'm supposed to introduce the other one because the alcohols are outside. And then after that, what did you do? Did you do aldehyde? Yeah. Aldehyde are also outside, around the fence. And from there, what did you do? Ketone.
Yes.
Ketone is they're there. Actually, they go as partners, ne? Aldehyde, yeah. And then also the alcohol. No, before you get carboxylic, it's alcohol and the other ones, but they didn't make you do it. Okay. All right. So what I'm saying here, watch now. This is hydrogen. The OX, we normally call it you can call it hydroxide or hydroxyl. Hydrogen and hydroxide. So this one was supposed to be called dehydrohydroxygenation. But anyway, we know it makes water, né? Yes. Another name of water is hydrate, okay? Hydrate. Hydration. Hydration means you've got water. Dehydration, you have removed water. So they figure out, these guys here, we are going to remove the H and the OH, okay? So, which means I remove the OH and the H, and then I'll have a double bond. When I put them next to each other, it's H and OH. And somebody says, why do you write it like that? You can see there are two H's there and one O. Like, it's water, miss. You see? Yeah. Then it's hydrate. So the name becomes dehydration. I would have loved it if they call it dehydrogenation. I want the genation. So dehydration. So they say now alcohols, you see the OH is for the alcohols, né? Alcohols can undergo elimination via the loss of water. Yeah? Alcohol loses what? That's why you find people who are at the shebeen drinking too much. They love to go to the bathroom. You know that? Yeah, they drink alcohol, so they must release water. That's a good example. Hello, Nana. Good. Then it forms that. So in this case, where there is an OH, you know it's what? It's an alcohol. Am I right?
Yes.
Let's go here. This one, where there was a chlorine, because remember it's single bond, which means it's alkanes. But these alkanes, they've got the halogen group. Am I right? So they are called what? The haloalkanes. You did that. Am I right? Yeah. Okay. Where they will say dichlorobromomethane or ethane, all of those things. Am I right? Yeah. Okay. So this one, did you understand what we did? We eliminated 3 things. Am I right? Ne? Now we are going to do a reverse of this one here. Because for this one, a catalyst will be an acid and energy or